Hey guys, we're going to do the Chapter 1 AP Stats practice test. You're going to want to take notes on another sheet of paper and then take pictures of that to upload. Okay, so it starts on page 86, as you can see up here. And I just put this on here so I have room to write. I am going to do all the questions on here. So question number 1, it says the airline records show the following variables. So the model of the plane, the amount of fuel, the time in the flight, the number of passengers, and whether the flight arrived on time. So you think about what those answers would be. The model of the plane would be something like Boeing. So that would be categorical, right? Amount of fuel used. Okay, so that's like 5,000 gallons. And that's going to be continuous, right? Because gas flows out of a gas pump continuously. This was the gas pump. Gas just comes flowing out on the ground. It's continuous, right? The next one, time in flight. All right, so it could be, 2-hour, 27-minute flight, and it could be X number of seconds, right? So time is continuous. Number of passengers. All right, that's going to be discrete. So maybe there's 137 people on the flight, but that is discrete, right? Next, whether the flight arrived on time. So that's a yes or a no, right? Yes, it arrived on time, or no, it did not. So I'm getting a total of 2 categorical datas and 3 quantitative and 2 continuous, 2 continuous. So final answer, C. Question number 2. The students in Mr. Tyson's high school stats class recently asked if they preferred pasta or pizza or donut party. Okay, so these are all categorical questions, right? You want a donut party, yes or no? Pasta party, yes or no? Pizza party, yes or no? And we quantified how many people said yes. All right, it looks like this is 5, this is about 18, and this is about 7. So, is the graph misleading? Absolutely. It looks like the graph is misleading because it looks like pasta is way more preferable, but what's missing is the bottom of the graph, right? So 4, 2, 0. Really, donuts and pizza were not as far off from one another as this misleading graph would appear. So you can redraw the graph, 5, 10, 15, 20, to show you understand how if it was drawn a little more accurately, the data would look different than the data displayed. It is misleading because the vertical axis should start at 0. All right, T 1.3. 40 students took a statistics test. So there's 40 dots there. And that's a dot plot, right? They took a stats test worth 50 points. So the points are here, right? It doesn't have to do with how many students there are. It has to do with what score they got. What would be the third quartile? Okay, so we know that we've been talking about a 5-number summary, max and min. Our median is in the middle, and our quarter 1 is in the middle of the bottom, and our quarter 3 is in the middle of the top. So they want just the third quartile. So 40 scores, if I divide by 2, is 20, meaning the median won't be an actual number. There'll be 20 to the left and 20 to the right, and I'll have to average the 2 numbers in the middle. So let's count in 20. All right, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. And you could verify that this is 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yes. All right, now we want the middle of the top. So the middle of the top would be 20 divided by 2 again, would be 10 and 10. So it's not going to be an actual dot or number. It'll be the average between the 10th and the 11th dot of the upper half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So it's in between that dot, which means it's the average between 44 and 44, which is 44. And that is one of my choices. All right, now for the other side. In recent weeks, data on the age of all homes sold in a particular area was collected. So this is a histogram, meaning I asked quantitative data and we counted how much. Notice the bin width is counting by fives. Okay. Which of the following could be the median? All right, so we have to know how much data we have, just like we did in the last one. So let's count that up. So we have 7, 8, 9, 7, 6, 3, 4, 2, 1, 1, 3, 1. Right, so we have 15, 16, 10, 13, 2, 3, 4, 5, 6, 7, 8. All right, so I got 52 numbers. Which could be the median age? All right, so I'm looking for half of that. $26. So this would be 15, right? Plus 9 is 24. So this would probably be 25, 26. It would be somewhere in this bin width. All right. So what would be in that bin width? It would be something between 15 and 19.9. Repeating. So that looks like wait a minute, wait, I'm counting on the wrong one here. Hold on. I said it's this one, and this one makes 24. And I'm trying to get to 26, excuse me. Okay, so I'm here in this bin, 24, 25, 26. So it's in this bin. Yeah, so it's somewhere between 20 and 24.9. Repeating. So the only number in that range is B, our final answer. Now, if you remember reading on this bottom part, this question goes with, that data goes with question 4, 5, and 6. So question number 5, which of the following is most likely true? Okay, so anytime you have data that's skewed, right? We noticed the median was somewhere about here. We noticed when we added really big numbers, like the group that had 40 colleges they wanted to go to, then the minute we added that, the median went from 15 up to about 17. but the mean, which was 15, then jumped all the way to 20, right? So that's what happens is if you add data that before you add it was relatively symmetrical, and then you add some higher numbers, it's going to increase the mean. So in this problem, the mean would likely be quite a bit higher than the median because of this higher end data skewing it. So as we see this here, it looks like the mean is greater than the median. So we can eliminate these. And what about the range? Well, we won't know the exact value because it's not a dot plot, but it looks like the min is about somewhere between 5 and 9. So at the highest, it would be 9, and 9.9. And the max is somewhere at the highest, it would be, maybe 74 point something. And so you can see here our range would be 65. And the IQR is always something narrower than that. It's the middle of the bottom and the middle of the top and the distance between there. So in this data, it looks like that would be more like the IQR would be something like 35 minus 15. Notice that's quite a bit less than. So the range is always going to be greater than the IQR. All right. Number 6, the standard deviation of the distribution of house age is about 16. Okay, so they calculated this for us and said it's about 16 years. Interpret this value. Well, we found in our notes that I'm going to go back and actually take a snapshot of that. So again, try to encourage you guys. Do I have it here? Oh, I'm in my quiz file, not my, sorry about that. Go back and standard deviation. What is it? We said that the standard deviation is the context typically varies by blank from the mean of blank. That's what that means. The context typically varies by blank from the mean of blank. All right, so looking at our choices here. It looks like choice E, the age of the house typically varies by blank from the mean age, and they didn't give the mean age, but they didn't have to. That matches our script. All right, 17, or 1.7. The mean salary of all female workers at a company is $35,000. The mean salary of all male workers is $41,000. What must be true about the mean salary of all workers? Okay, so the mean, we can think of these as if we didn't know it and we knew there were 10 women working there, we could multiply this and we know in total the salaries add up to $35,000, right? And in the same way, if we don't know how much the men are making, we could assume there was 10 there, right? And that'd be the total sum. And so now in this scenario, to find the total new mean, right, we'd add up everyone's salary, which would be the sum of all of them. 760, right? And it looks like I'd add up the number of people I'm talking about, which I just kind of made up a number. And you don't have to make it up a number here, but when you make up numbers, you can kind of see, oh yeah, that would definitely not just happen sometimes, but all the time. So in this scenario, when we made equal amounts of men and women, we noticed that no matter what, it's going to be greater than 35,000. It must be, oh, that's weird. I got that value, but you know what? I just arbitrarily made up that 10, didn't I? Right? It must be larger than the median. Well, we don't know if the mean and the median are larger than one another because we don't have any data. There could be some low outliers or some high outliers. It could be any number between there. Yep. And so that's where I'm settling in. It has to be a number between there because the average person makes between 35,000 and 41,000 in total. So the average of everyone would have to fit between there. There's a scenario where it could be larger than 380 if I had more men. It can't be larger than 40. It absolutely could. We could have only one woman and like a whole lot of men, and that would make it larger than 40 grand. All right. Says this question refers to the following setting. A survey was designed to study the business operations by size. Companies were classified small, medium, and large. The questionnaires were sent to 200 randomly selected businesses of each size. So I'm just totaling the margin. Right? What percent of all small companies, so looking just at the small companies, what percent, ignoring everyone else, what percent of all small companies receiving questionnaires responded? So it looks like 125 responded out of 200. So turning that into a percentage. Well, calculator's being weird. And there you have it. That matches the answer we're looking for. Which of the following conclusions seem to be supported by the data? It does appear that small companies have a higher response rate than medium or big ones. Small companies have a higher response rate. And I don't need to normally I'd have to turn all of these into percentages, but notice I don't have to this time because an equal amount of each business size was surveyed. So I actually know that 62% of small, I could turn this into a percent to compare. So we did 125 over 200. To compare this, if it was different amounts, we would do this and we would do this, right? I know that this number is greater than these other two numbers. So I'm definitely going to pick B. Number 9. Oh, that was 9. All right. Number 10, last multiple choice. And then you'll want to make sure you do 2 out of the 4 free response and you're ready for that. Question 10, an experiment was conducted to investigate the effects of a new weed killer to prevent weed growth in onions. 2 chemicals were used, the standard weed killer and the new weed killer. Both chemicals were tested on high and low concentrations on 50 test plots. The percent of weeds that grew in each part was recorded. Okay. So we put weed killer on so that weeds don't grow. So it looks like this one had the most weeds, although this one had a couple of crops that had lots of weeds, right? This one looks rather low. So as we look at each of these questions, we have to be careful because it says which one is not correct. Okay, so it says both at high and low concentrations, the new chemical, so the new one, at high and low concentrations, the new chemical resulted in better weed control than the standard weed killer. This thing is lower than that thing, so I'd say that fits. Is this thing lower than this thing? That's harder. The median was lower when we compared them, but there's some other things going on, right? But it says the new chemical results in better weed control than the standard. So in general, if you're looking at just the median, the new chemical did better, meaning had a fewer percent. So I think that this one will be true. We got to look for a new one. Both chemicals, for both, smaller percentages of weed typically grew at higher concentrations. So when the concentration was high, it resulted in fewer weeds. Now let's compare the other one. When the concentration was high, it resulted in fewer weeds. Yes, on average, if I look at the median, it did. So I will have to say true. Next one. The results for the standard weed killer are less variable. Okay, so we're going to look at the standard weed killer are less variable. Is the standard narrower than the new one? Yes, it's much narrower. So that's a true statement. High and low concentrations of either chemical have approximately the same effect. Okay, now do these bars look exactly the same? The answer is no. So I think we found our answer that is false. We are definitely getting different results. Let's go ahead and look at the last one. Some of the results of the low concentration of weed killers show smaller percentage of weed growing than some of the results for high. Okay, and that's where we get into this some of the results. Some of the results for low concentration, so here and here, some of the results of low concentration show a smaller percentage of weed growing than some of the results of high. Yeah, that's true. You're seeing here. And again, they're just saying some of the results. All right, there you have it. Keep on studying. See you next time.